Okay, hello everyone. Today we're going to be looking at the topic of pulleys and looking how particles in pulley systems move and accelerate accordingly. Now, when we look at this system over here, you've got two particles that are the exact same mass and they are connected by a light inextensible string passing over a smooth pulley. Now, I've used a few phrases there, light and inextensible, referring to the string having no mass and the tension being constant throughout, and a smooth pulley, meaning there's no resistance in our pulley system. Now, when we look at the diagram in front of us, this system is going to be in equilibrium. It's not going to move. But we need to think about the forces that are in play for this diagram to make it clear for us. So in the case of each particle, all particles have weight. So I've got 2g coming down for this particle, and on the left hand side I've also got 2g as well. I've got 2g on the left and 2g on the right. Now at this moment in time there's not enough forces acting on the 2 kilogram block. Why is it not moving? Well, it's not moving because there's tension in the string keeping it in place, and at this moment in time that tension is equal to the 2g because the forces have to be balanced for a system to be in equilibrium. So here we can see this tension is equal to this 2g and this tension is equal to this 2g, and these are the forces acting on the particles. Now there is actually also tension in the pulley because the pulley is feeling force as well, like this, and there's a force coming up over here to just keep this system in equilibrium. This is the force acting on the pulley, keeping it in equilibrium. But we're not really going to look at that for now. That's just something which is important for us to understand a little bit later. So we can see here that this particle or this system is in equilibrium. Now most pulley questions, or all pulley questions, don't really look like that. I have a slightly different scenario for us to look into, and that is this one over here. The difference in this case is that I've got a 5 kilogram block on the right hand side and a 2 kilogram block on the left hand side. Now because the 5 kilogram block has more mass, it's going to cause this system to accelerate downwards on the right hand side. It's going to cause this acceleration over here. Now because these particles are connected by a light inextensible string, it means that there's going to be acceleration up on the left hand side. But we've said we still need to label our forces on our diagram to make this easier for us. So the 5 kilogram block will have 5g coming down and tension coming back. Now that tension is linked to the resistance from the 2 kilogram block. As this is moving, it's getting resistance from this block over here. The 2 kilogram block is going to move upwards because the tension over here must be larger than its weight over here. So here we have the forces acting on the particle. Now the question is asking us to find the acceleration of the system and the tension in the system, or the tension in the string. Now to do this, we've said that this is a connected bodies question. When we do connected bodies, we can either treat the whole system as one, or we can look at each particle individually. That is the aim of this. Whenever I do a pulley question, I look at each particle separately. So if we look at the 5 kilogram block, we are going to use F equals ma in the direction of motion for the 5 kilogram block, which is downwards, 5 kg down. Now the net force going down on the 5 kilogram block is 5g minus t is equal to 5a. That is your first equation. If we apply the same principle for the 2 kilogram block, now the 2 kilogram block is not going downwards, it's going upwards. So we make our upward forces positive. Now in this case, that means the tension is our positive force, the 2g is negative. That gives us t minus 2g is equal to 2a. Now what we have here, what we've created are two simultaneous equations. So whenever we do a question like this, I'm going to make a little bit of space on the right hand side. We solve these questions accordingly. Now for pulley questions, you always get one equation with a negative t and the other equation with a positive t. And what you do with these two equations to cancel out these t's is you always add them. If you add them, those two tensions will cancel out. If we add this together, we get 5g minus 2g is 3g is equal to 7a. And that means a is equal to 3g divided by 7. Now, the value of a we've seen previously, the value of g we know as 9.8. So if I multiply that together, 3 times 9.8 divided by 7 is equal to 4.2. So the acceleration of this system is equal to 4.2 meters per second squared. Now, once we have worked out the tension or the acceleration, we can now work out the tension in the exact same manner that we've done so. So we now put this over here. It's a simultaneous equation. All we are doing here is working out the value of t. So we need to substitute into one of these equations. Now the equation I'm going to sub into is this one over here. So we can say that t minus 2g is equal to 2 times by 4.2. That gives us t is equal to 2 times by 4.2 plus 2g, so 8.4 is the 2 times 4.2 plus 2g. Now 2 times by 9.8 is 19.6, and then if you add onto that the 8.4, you get a value of 28 newtons. And that's it. What we've seen there is we've done F equals ma on the first pulley, then F equals ma on the second pulley. We've created two simultaneous equations. We've added the two equations to eliminate our t's, found the value of a, substitute in to find the value of t. And that's how we would look at pulleys in this manner. Now, I've got a second example, which is a little bit different, which I'm going to show you right now. This was a question where we were given a diagram to start with. This second question is slightly different, where we need to read the question and create our own diagram. So it tells us over here that two particles of mass 10 kg and 4 kg respectively are connected by a light inextensible string, and it again passes over a smooth pulley. Now B, which is the second particle, rests on a smooth horizontal table, and A hangs 3 meters above the ground. So a little bit different this time around. It's saying that B is on a smooth horizontal table. What that means is when I draw a diagram, I have to have a smooth horizontal table over here, and I've got my pulley system up here. Now that means that this is our particle B, this is my 4 kilogram particle, and over here is my 10 kg particle. Now, once again, we need to still make sure that we've got our forces in our diagram to make this easy for us to work with. So over here, this has a weight of 10g and tension coming up. This has a weight of 4g, but the tension this time is going to the right because that is the direction this is getting pulled in. There's also a reaction force up here. We also know that the question tells us that A is 3 meters above the ground. Now, if you're being told something is 3 meters above the ground, that links to a different area of mechanics, which must be our SUVAT. We're bringing in distances when we're working out acceleration as well. So starting point, exactly as we did before, is to work out the tension and acceleration of the system. If we do F equals ma on our 10 kg block, 10 kg block is going to accelerate downwards. 4 kg block is going to accelerate to the right. So 10 kg down means the 10g must be greater than tension. 10g minus t is equal to 10a. If we look at the 4 kg block, F equals ma, 4 kg to the right. Now, the most common mistake that I see generally is people write t minus 4g. T is going to the right, 4g is going down. The 4g does not affect the left and right motion here. So this is going to be simply t is equal to 4a. If we add those two equations together, 1 and 2, or substitute this into here, we get 10g minus 4a is equal to 10a. We rearrange that, we get 10g is equal to 14a, so a is equal to 10g divided by 14, 10 times 9.8 divided by 14 is 7 meters per second squared. 7 meters per second squared. And if we are working out tension, we are simply substituting back in. If we sub this in, we can sub this value in over here into our acceleration. T is equal to 4 times by 7, which again is equal to 28 newtons. And that's part A done. That is finding the tension and acceleration of the system. Part B refers to the speed of A as it hits the ground. It's going to travel for 3 meters. This becomes our SUVAT style question. So we need to incorporate our other SUVAT values, S, U, V, A, and T. We know the distance is 3 meters. The initial velocity, well, this is starting from rest, must be 0. And the acceleration we worked out previously as 7. If you are working out the speed of A as it hits the ground, you are simply using one of your kinematics formulae, which is going to be v squared equals u squared plus 2as. V squared is equal to u squared plus 2as. V squared here we don't know, u squared is 0. 2 times 7 times by 3. 2 times 7 is 14. 14 times 3 is 42. That is v squared. Therefore, the velocity which A hits the ground with is the square root of 42, which is 6.48 meters per second. That is your final answer. And that is the full question completed. But once again, we followed the system of doing F equals ma on one of the particles, F equals ma on the other particle, solving the simultaneous equations by adding the two formulae together, and then using the acceleration from the question and applying it to the SUVAT below. I hope that's made sense. If it hasn't, please comment below or let me know.